This video is about what DeepSeek R1 really means for AI. I think there was a big hullabaloo about the amazing developments, and I think it comes down to, and it doesn't even really matter what the benchmarks are because they don't really mean what most people think they mean, but it scored very similar to O1 on a lot of the benchmarks, and so people were going crazy, especially with the fact that they released costs that were orders of magnitude less than what it took to make for OpenAI, Anthropic, and the other model companies to make their models. So let's take a look at the benchmarks versus reality first of all. I think the expectations based upon the benchmarks don't really fit the reality, just like this meme. The benchmarks, as I mentioned, put it on par with O1, which sounds really great. But the real world usage just doesn't live up to this. It's not just me, but other people have noticed this as well. It's just not as good at using real world use cases as even sometimes like GPT-4o or Claude. Not even to mention like O1 or O3 or any of those other models. It's just always a bit worse. And I think if you go out and play with it, which I recommend you do, you'll notice this as well. So let's talk about the thing that was really jaw-dropping, which was they claimed basically that it took them $5 million to train. And there's kind of some nuance here. So is this true? So first of all, some of this we can validate because they did open source a lot of the information, but not everything. And there were definitely some new cost-saving techniques, like the way that they ran their pre-training at a very deep computational level, like even underneath CUDA, which is like a kind of like a C version for that NVIDIA makes for their GPUs. They kind of hacked that and got some really big cost savings there in the way that they train it and in the way that they run inference. So it's not just less expensive to train, but it's also a lot less expensive to run. So that there's definitely significant major cost saving techniques, but there's also definitely some lies. Like I think there's very good reason to believe that they used more compute and more advanced GPUs than they claimed, because they can't really be honest about it. It's China, so there's several different kind of factors there, both from the China side and the U.S. side, in terms of not allowing them to be fully honest. And so there's also some aspects of it that we don't really know. For example, did it use distillation on OpenAI, which is hilarious. So if you don't know what distillation is, it's basically using the outputs of another model in order to train your own model. And this happens a lot and is generally reasonable, although technically in OpenAI's terms of service or whatever they want to call it, they're not supposed to do this, which is hilarious because they basically, without the permission of the people on the internet, trained their models on all the internet. And there's reason to believe that they actually did do this. And just because it says it's OpenAI or ChatGPT or whatever doesn't necessarily mean that this is exactly what happened. But it's very reasonable for them to do this. Honestly, this does seem like the area where I would be most concerned about if I were other foundational model companies, which is that the cost savings that they have found are just absolutely massive, orders of magnitude better in a lot of ways, and in terms of training and inference. And it also would make me question a lot of the assumptions around foundational model companies. If this is even half true, if it really costs $10 million, then that's still like nothing compared to what it costs to train GPT-4, which is probably we don't know the exact number, but by estimates, somewhere on the order of $1 billion. So let's see, so 10% would be 100 million, and 10 million would be 1%. So let's say it's about 1% the cost, 2 orders of magnitude to train. That's a huge, huge jump. Now, maybe there's a lot more room to tap there to where it can even go way down further. This is like computational algorithmic techniques that dramatically reduce the cost. For example, one of the ways that they do, I don't know if this saves on pre-training, but it definitely saves on inference. So they have the mixture of experts. But GPT-4 is like 16 experts. I believe that the DeepSeek is like 200 something experts. And so essentially, and then I think Claude and some other models, I think Gemini is not a mixture of experts. And so what that means is when they go to inference, the whole data set, all of the kind of cells, neurons are activated in those if there's no mixture of experts. But with this one, they use a much smaller amount of the data training set essentially, and that's how they save money. And so, but this increases the complexity of the model, which is why when somebody says, "Oh, it's always better simple," not necessarily true. This does seem like something where there's probably even more that can be tapped into it. What if they take that 200 to 2,000 and they narrow it down? They break it up into even smaller bits and they narrow it down even further. Maybe there's more orders of magnitude of cost savings to be gotten there. Okay, so foundational model companies. This is so wild to me that this is one thing that I think gets glossed over the most, and that I am surprised that there's not more talk about this. Actually, well, NVIDIA in the stock market got hit the most. I would think that the value of actually and this is not necessarily in the stock market, except with Google potentially, but with Anthropic and OpenAI, their values should have just halved or more based upon this alone. And there's more. I have more reason to believe that their long-term value is actually not quite what people think. But first of all, I'll say I'm grateful for the foundational model companies. Like, we wouldn't be where we're at without OpenAI. Let's just be clear about that. But that doesn't mean that they are going to be the leading player or even a significant player in the future with AI. And so I'd be feeling really shitty if I was like an investor in the latest round of OpenAI, because while they might get some future bigger rounds, this is not a good sign. There's a saying in business where it's essentially the pioneers get arrows in their backs. And so let me give you an example of something where a set of companies invested heavily in an area that we benefit as a society from, but they didn't actually make the money. Those investors footed the bill for developing, and that's like fiber optics. So there were companies that built all this fiber optics, but they couldn't make money, and so their assets were purchased at a major discount, and we get to benefit from fast fiber optics nowadays. So I would actually estimate, and you can, if you disagree, let me know in the comments, because I imagine a lot of people disagree. It's hard to see the front runner OpenAI losing it all in the future. But based upon this, and actually I've been saying this for a while, I actually think that the chance that they are a top tier company, that they are really making a lot of money in 5 to 10 years, is below 50% for both of these companies. Especially the longer that they stay essentially just being a foundational model company. Now, O1 and O3 is a move away. It's like a slight step away from being a foundational model company, but it's only just a tiny bit. They need to move much further. And I think with the operator that they're trying, that's a good step in that direction. They try to do the custom GPTs and the plugins and all that stuff. They really have failed in all those areas. And what is keeping them alive is the fact that ChatGPT still gets used a lot. But really, if you look at it, ChatGPT is like just a wrapper around their cutting edge models. But over time, the amount of use cases out there will be taken up as a higher percentage of open source is going to be able to do it. So let's say right now, and this is just a random number because there's no way to get this exact number. Let's say open source can do 50% of the use cases with AI that you'd want to be able to do. That's possible to do right now. And then the other 50% would be these better foundational model companies. That number is going to go up. Now, the total amount of use cases possible will also increase, so maybe we'll find different use cases. And also, I don't think it'll ever go to 100%. I think there will always be special models that are needed for special cases. But it, as a percentage of the total market, I would be pretty surprised if it doesn't decrease significantly and get to something on the order of 80 to 95% of the possible uses for AI in the next couple of years can be handled by open source, if not this year. And that is one of the death knells for that R1 points towards. If it was as good as its metrics, as the benchmarks, it would be like it's here now, because basically you can run it for free, not for free, but you can run it at a significant cost. And if it was just as good as these other models, why would you use OpenAI and Anthropic at all? Except to the extent that they're already integrated into your systems if you already got stuff. So you just have to pay the transition cost. I think that day is coming where maybe these foundational model companies, if they're only 3 to 6 months ahead of the open source on a consistent basis, that's not enough. That's not enough for them to survive as a model company. I think the companies like Google, even though their models aren't quite as good in general, they could still survive because they have other aspects going on in their business, and so that's probably the company that could continue to survive. And then Meta, I think Mark Zuckerberg's looking really smart right now, investing in open source, and not actually selling the model and the outputs of the model as part of his business model. So that is why I've been seeing that for a while now, for almost 2 years now, and so this is a really, really strong signal that backs that right there. I think that they're going to end up being like, we needed OpenAI to do what they did, but just because they built the first models and they took us there doesn't mean that they're going to be the ones that are going to benefit from it as a company. All right, test time compute ceiling. All right, so there's this idea, and I'm going to see, do I have it here? Well, I think I'm going to mention it a little bit further, but there's this kind of illusion of progress to some degree. And so that a lot of that comes from seeing benchmarks and seeing the improvements in benchmarks, or somebody really seeing something new, or that does something a little bit different or a little bit better in an area, or has a better benchmark. And so it does seem like, oh my God, we're doing so much better, because with this test time compute, essentially what they've done is they've narrowed the data set to better reasoning for a very narrow slice of use cases. But then those are the benchmarks that they show: coding and math, things where there's hard answers. They are able to, with the fine tuning, they narrow the data set to the best parts of it. This really only is helping with what I would call kind of hard answers, which again, where there's a definite answer for something, versus soft answers. Even coding has a little bit of squishiness to it, even though there is kind of a right answer, or like a way to be like, okay, does this have bugs in it? Does this really get what you want? Maybe yes, maybe no. And so basically what we saw was since GPT-4 came out, if we just look at the model, forget about chain of thought or anything like that, we just look at the model, though the models have not improved that much. On the same pace, let me rephrase that. The models have not improved on the same pace as they did from like GPT-2 to 3 and 3 to 4, as they did since GPT-4 came out in April of 2023. So almost 2 years ago, the models themselves they've improved, but it's not like on nearly that pace. Okay. Now, with chain of thought, which is several-year-old technology, credit to OpenAI to get it to work to some degree, although you could already kind of do that. The way that they fine-tuned it, I think, was pretty clever, and so they get credit for that, and that there is still some room to tap in that area, but it has a ceiling, and it's not really going to help that much with the soft answers. And for some of the hard answers, it's going to help a lot, like with math. I think math is probably the one where the answers are the hardest, and so in that sense, it's going to help the most. With coding, I think it's not quite so simple. There's still a lot of aspects of LLMs that LLMs really have trouble with coding, and they kind of paint themselves into a corner consistently. There's not that much data in their training set that points towards how to actually use large language models within code, and they will have trouble creating new things essentially. And I think that there will still always need to be, I don't really like the human in the loop, but like a human kind of guiding and checking up on and utilizing the LLMs versus them just kind of being given an instruction and put on a loop and told to go. And to some extent, what they're doing is they're brute force computing. If you saw the the amount of tokens they used in order to pass some of those benchmarks with O3, it was like, I think it was like in the billions or hundreds of millions or something. It was crazy. They spent copious amounts of money to solve those problems in a way that's not practical. Now, R1 points to a cost savings that I didn't expect, so I'm a little bit wrong about the significant cost savings that came from that. But this has its limits, and it reduces the practicality, barring further cost savings for this to actually solve things. So it's a narrow slice of the use cases that are actually going to get improved with this. And there are still limitations to LLMs. They still, O3 still hallucinates. Go look out, go test it, and all the models still hallucinate in a way that is that dramatically reduces their use cases in a lot of scenarios. And so that in and of its, or at a minimum, you have to build additional systems around that to handle those, which is possible in lots of scenarios. So where do we get the real value from? Where can you mine the real value from? And I've heard people say the app layer. I don't really like the kind of the layer versions of talking about different aspects of like the software and the hardware stack. I think it implies there being much more of a discrete boundary when things are much more integrated than that. The way I would put it would be how to leverage LLMs. And specifically what I've been working on and we've been working on at our company for the last 2 years is LLMs as tools within software. So essentially, if you think about LLM as a new tool that we're giving to software, all software prior to LLMs was essentially deterministic unless you intentionally injected like randomness in there or there was like a hardware error. But now, as you're using LLMs, there's a randomness to that. And that is non-trivial, and the way to use it is non-trivial. And there's a lot of nuance to doing this, as we've discovered within actually using LLMs as tools. And again, this is the backwards to what most people are doing, where they're having the LLM use software as tools, and I think that's backwards. In most cases, I think it works for very simple things, but for the more complex things, it's better, in my opinion, to have software, deterministic software, be the structure, and then the LLMs be tools that are used at places in narrow ways, and only in places where you couldn't already do software or was impractical. So conclusions. I don't invest in foundational models. That's what I would suggest. Because there's a really good chance that this becomes completely commoditized or 90+% commoditized. So if you're worried, I didn't get to invest in OpenAI, how dare they not allow me to invest? I wouldn't worry too much about that. There's a chance that they could survive, but they're going to need to go beyond the foundational models and be more than that. And then I would invest in basically how to use LLMs as tools. Technically, it's the app layer. I think there's a little bit of a distinction between that for me, which is beyond necessarily apps, because I don't think a lot of the stuff we do here at my company is not necessarily an app, but it is using an LLM as a tool within software. I would always try to consider their models being hot swappable in your processes, and that doesn't mean they have to be completely hot swappable, because there's going to be nuance and differences between how some of the models are used. But in general, for us, if a better model comes out tomorrow, we can go and put it in our processes for all of our stuff, and it shouldn't be a big deal. Maybe the prompts need some tuning, but in general, they get easier to use over time. So in some cases, you can just straight up swap it right in and out. Will we have further compute cost savings? I think this is a really big bottleneck. This one, it's hard to tell. I don't think I know enough about the deep technology of the compute and CUDA and stuff like that. I've looked at CUDA code and I haven't really done any coding with it. So I wonder if there's still some bigger cost savings. My guess is that yes, there's still some significant cost savings left to be done there, which is even worse for the foundational model companies, better for open source, better for AI kind of spreading out there. And so I think that they're just starting to tap that surface there, and it kind of makes that Stargate program seem a little silly. Additionally, I really want to caution everybody against the feelings of change. I hear all the time, oh, things are changing so fast. And in some sense, that is correct. But in a lot of ways, it feels illusory. It's an illusion. And a lot of this comes from benchmarks. When somebody makes an improvement in a benchmark or somebody comes out with a new thing. And a lot of this also has to do with people hyping AI for their own personal benefit. They, by making things seem like they're changing faster, it's good for them. It makes people kind of a little bit crazy, and it makes them feel like they have to pay attention more to them. And so by telling you this, I guess it's, disincentivizes you from watching my videos. I'm going to do a little bit wider range of stuff than, it's crazy, it's changing so fast. I think things are improving, but it is in fits and bursts, as we talked about. Basically, the LLMs themselves have not improved at nearly the same rate over the last few years as they did the previous 2 to 5 years. So are they changing fast? Is the technology changing fast? In general, that speeds up over time, but it doesn't happen. It's not nearly as linear as people think, and there's definitely lulls and then bursts and significant changes. So let me know what you think. Please like this video if you're still with me, and subscribe for more like it. Hope you have a great day. Thanks for watching. Bye.